So page 5 starts our review of linear functions. Before we were looking at just general functions. Now we're just looking at lines. And the thing that separates a linear function from all other types of functions is the slope is the same. So no matter what points you're looking at on a line, the slope or the steepness of that line is always the same. And when you have linear functions or lines, you use the equation y equals mx plus b. M is the slope and b is the y-intercept. One other thing I want to note up here is the rate of change or the slope. When you're looking at how the y values change, it's a constant adding or subtracting number. If something has a pattern that's multiplying or dividing, it is not linear. Or if the adding or subtracting number changes, it's not linear. So it's weird how this is set up, but these are linear equations down here. The first thing we're going to do before we get into lines and other things is solve for x. And then it just says remember to distribute first. So now I'm going to show you how to do this 2 different ways. Although, we've done this in class, but this is a review. So let me get rid of this purple thing. I want to zoom in a little bit. There we go. Actually, I want to zoom in more. So we have our little river, cobblestone path, whatever you want to think. That's our equal to. In order to cross the equal sign, you have to do the opposite. To start, though, we're working on the same side of the equation. So you just do whatever the problem tells you to do. So I'm going to distribute 2x, and 2 times 3 is 6. Bring everything down. Now, when you're solving an equation that doesn't have exponents, you want to get the x's on one side and the other numbers on the other side. So I'm going to minus 6. To jump over this equal to, I have to do the opposite. 2x, be careful with your negatives. You can put in your calculator -8. Whoops, use the little, that's a mess. Use the little negative button, -8, subtract 6, and you get -14. And then divide both sides by 2, and you get x equals -7. Before we move on, we are going to look at how you could also do this using the graphing calculator. And again, my calculator is kaputz on this Chromebook, so you're going to have to try this on your own. You go put into y equals, this side goes into y1, this side goes into y2. Then you look at the graph and you want to see where these 2 lines crisscross. So you do second trace button, number 5, and then you press enter 3 times. Enter, enter, enter. And it's going to give you a point. You're going to get the point -7, -8. When you use this method, you choose the x value. So you would say x equals -7. Even if you're really, really comfortable with solving equations, it's good to practice this. Remember, we're reviewing and practicing. So what you are going to do right now is solve each equation, and then you're going to type your answer into the Edpuzzle question. So when I solved this equation, I distributed first, and I got 2x plus 3 equals 23. And then I wanted to move my plus 3 to the other side of the equation. So I minus 3 on both sides, and then they canceled out. And I got 2 times x equals 20. So then I divided by 2. So for equation number 3, we have fractions. Gross. So this is one, even if you're solving this using your showing work, getting x by itself, it's always a good idea to check your answer using your graphing calculator, you have it there. You might as well make sure you're not making any silly mistakes. I make silly mistakes all the time. So we have these numbers. They don't have an x attached to them. So we're going to combine like terms. If you didn't want to do this, now you could add 1 to both sides of the equation and then add 3/5. You'll get the same answer. So I'm going to bring down my 6/5 x. Negative 3/5 minus 1 is minus 8/5 equals 4. And then I'm going to move my minus 8/5. So I'm going to add 8/5 to both sides. And I have already run out of room. Let's see if it lets me. Oh, hooray. So the 8/5 cancel out. So I have 6 over 5x. 4 plus 8/5 is 28 over 5. Now, to get x by itself, you can either divide by 6/5 or you can multiply by the reciprocal, which means flip the fraction. It doesn't matter. Dividing and multiplying by the reciprocal mean the same thing. So those cancel out. So you get x equals, now you might get 14 over 3, or on your calculator you might get 4.66666666. I would highly recommend just leaving it as a fraction. If you must write a decimal, make sure you round it appropriately to 4.7. Where I want to clear this thing. These are getting progressively trickier. I'm going to copy down 4/3 x plus 2. Now distribute. Negative 2 times 1/3 x is negative 2/3 x. Negative 2 times negative 3 is a positive 6. There's fractions, there's negatives. Great idea to use that calculator trick to check your work. So now, here's my equal to. I'm going to put the x's on the left side of the equation and the plain numbers on the right side. I'm going to add 2/3 x. That's a plus, you can't really tell. Plus 2/3 x. Definitely going to run out of room on this one. 4/3 plus 2/3 is 6/3, which simplifies, thankfully, to 2x plus 2 equals, that goes away, 6. So now I'm going to minus 2 on both sides. And I'm going to write my work off to the side. 2x equals 4. And then divide both sides by 2. So x equals 2. The last section, which of the following tables represents a linear function? Explain your answers. What you're looking for linear is that the y values, the output, change by a consistent adding or subtracting. Typically, this doesn't happen as far as test taking goes, but make sure your x values are going up by the same amount. So this x goes up by 1, 2, 3, 4. They're increasing by 1. The test writers could be, if they wanted to be really mean, like 1, 2, 4, 9. Then you would have to actually use your slope formula to find the slope, which is y2 minus y1 over x2 minus x1. Typically, though, you don't have to worry about that. It's just good to check. So let's do this first one. We know all the x values are going up by 1s. So now we just have to look at the pattern here. How are these y values changing? In this case, they're changing by minus 3. Since it's changing by the same subtraction, it is linear. Now, explain means in words you have to say, why is it linear? So I said on my paper, the rate of change is constant. You could say the rate of change is the same. You could say the slope is constant. You could say it's, oh, here go my dogs. Each point is going down by 3. As long as you say something about everything being the same, you're good to go. Okay. Dog crisis averted. There was movement outside our window, so therefore they freaked out. Let's see, where were we? So now is this table over here? Does this represent a linear function? So what you are going to do over on the side is say what these y values are changing by. So if you're not sure, I know these are going up, so I know we're adding 85 plus, I don't know, is 177. You can always work backwards. 177 minus 85, that gives you 92. So that means this is going up by plus 92. You could do 177 plus 92, see if you get 269, or you could do 269 minus 177 equals 92. Same thing here. 361 minus 269 gives you 92. So all of these points are going up by 92 on the y. So we would say the same thing as before. It's linear because the rate of change is constant. Change. And I ran out of room, so I'm abbreviating that. Whoopsie. For these bottom two, both of these are going to be non-linear. Just throwing that out there, spoiling the surprise. Okay, let's see. So I double checked. The x's are going up by 1, so we can ignore that part. When you look at the pattern here, if it's going up, so you can think add. This is going up by plus 5. This is going up by plus 2. No, not plus 2. Oh, dang it. Plus 5, plus 10, and this is going up by 20. So the rate of change is not constant. It's not staying put. There's a common factor. All of these are being multiplied by 2. So as we know from what we've done in the past, this is an exponential function, but they're not asking that. We would say nonlinear or not linear. And our reason, the rate of change is not constant. So if these are going up by 2's, multiply by 2, times 2, if the y value is increasing by a multiplication factor, what type of function is that? If it's going up by a multiplication factor, it is exponential. Now this guy over here, the last one, that's going down by minus 12. To go from 4 to negative 8, that's a minus 12. But to go from negative 8 to negative 19, that's a minus 11. It's close, but it is not linear because the subtraction is not the same. So I'll write here, rate of change is not constant. Constant means the same. And remember, explain. I'm putting a T there. You can't really see it though. Nope, still can't see it. I'm putting it there. In order to be a line, that slope, the way the y value is changing, needs to be the same for each point.